Welcome everybody. This is your video lesson for Unit 4.1 and 4.2. We're going to kind of roll these into one here. Today we are solving inequalities and compound inequalities. Okay, so we're going to use some of our skills for solving equations, and we're going to mix in a couple of new rules here today. All right, so inequalities are an open statement that use greater than, less than, greater than or equal to, or less than or equal to. Okay, so an open statement means that you will have multiple solutions. Okay, so it's now not just x equals 5, it's x is greater than 5, and we know that there are an infinite number of solutions that would satisfy that statement. Okay, so the new rule that I was mentioning today, when you are solving, okay, when you're solving inequalities, anytime that you multiply or divide a negative number, and we want to kind of add here, multiply or divide a negative number to the other side of the equation. Okay, you must flip around your inequality symbol. So if it starts as a less than and you divide by a negative, you're going to make it into a greater. And the same thing if it is equal to. Okay, so they will flip between each other. So let's see some of this. Okay, so if you have graphed inequalities on a number line, okay, we know that when it's just less than or greater than, we use an open circle. And when it is equal to, we use a closed circle. Okay, so if it is something like x is greater than 5, okay, when we put 5 on the number line, because this is not equal to, we put an open circle around that. Okay, and then we would shade. So while we're looking at a number line here, for my requirements, a very simple number line like you see here is more than enough, okay? I only need the value in question, okay, meaning 5. You do not have to put tick marks of all the other numbers around it, okay? In fact, I don't want to look at that. And when you shade, okay, please do not just darken the line. I'm not going to be able to tell. You want to actually use an obvious squiggle here. Okay. All right, some key words that we're going to need in the future for translating word problems. At least or no less than. So these are two separate statements. Okay, they both mean greater than or equal to. So these are kind of turnaround words. Okay, it says at least, but it's actually referring to a greater than. And then at most or no more than, those are less than or equal to. Okay, so we want to make sure that we have those two down when we are translating. All right, so we're first going to solve some simple, these are just regular inequalities, okay? Keeping in mind that one rule, when we multiply or divide by a negative, we have to flip our inequality sign. Okay, so we're going to use all of the same skills for solving, which means SADMEP. Okay, we're just going to keep in mind our inequality. All right, so we're going to subtract 6. All right, so now I'm dividing to the other side of the equation. I'm dividing by a negative number. This is the rule that we just talked about. So that means I have to flip my inequality. Okay, so this turns around. So that is my answer. And now I have to put this on a number line to graph. So remember, when I graph, just the one value in question, no other tick marks. Okay, now I'm going to determine, is this an open or a closed circle? Well, since it is equal to, since it's equal to, it's a closed circle. All right, and this says greater than 3. So I'm going to put my shading. Please make sure you use an obvious squiggle line. Do not darken the line. Okay, and this graph is part of my final answer as well. Okay, hopefully you didn't find that to be too terrible. All right, let's try another one. So I have distributing. So I'm going to do that first, just like when we solve regular equations. Okay, move the smaller variable, which is negative 5g, to the larger variable. Right. Now, when we finish here, we're going to have our variable on the right side. Okay, especially for inequalities, it's best to have your variable on the left. And we can just flip this right around and put our variable on the left, and you want to just make sure that the inequality is still pointing in the correct direction. So we see in our original answer here that it's pointing to the G. So when I flip it in the other direction, okay, to put the variable on the left, I just want to make sure that it's still pointing to the G. Okay, so that is my final answer, and the reason that I put the variable on the left is that it helps me determine shading. All right, so I'm looking for -1 on my number line, an open circle because it's not equal to, and see how with the variable on the left, the inequality kind of looks like an arrow and it's pointing to the left. It's telling me where to shade. It's telling me to shade on the left side of my number line. Okay, but that only works if the variable is on the left. Okay, so again, these two are just regular inequalities, and the only extra rule that we have to remember is when you multiply or divide a negative to the other side of the equation. Okay, I have 2 more regular problems here. All right, so there's a lot of distributing here in this first problem. Okay, so let's get right to it. Okay, and we're going to combine like terms. Okay, so I have variables on both sides. I would want to bring the smaller variable to the larger one. Since they're the same, doesn't matter. So I'm going to move this guy from the left. Okay, and my variables are canceling out. So I get 28 is less than -27. Okay, well, I need to think about this for a second. Is this a true or false statement? Is 28 less than -27? No, this is false. Well, what do we know when we get a false statement? What is our final answer? No solution. Okay, a no solution problem, you do not graph. There's nothing you can graph. Okay, now side note to this, if we got a true statement, so let's say I have 0 is less than 5. This would be true. Okay, and I know that true is all solutions. So if you have all solutions, when you have the graph, okay, you want to shade the entire number line. You don't have to put any numbers on it, okay, but you want to shade the entire thing to show that it's all solutions, even if we put arrows here on the end. Okay, all right, so that's just a little side note there. All right, last example for regular inequalities, and then we'll get into what does compound mean. Okay, so subtract, move my variable, they're the same. Okay, so again, I have a false statement, no solution. Okay, so take a second, hit pause, take a deep breath. This was part 1 of today's lesson. These were the regular inequalities. Okay, and now we're going to move into compound. Okay, so a compound inequality is 2 inequality problems listed together in the same question. Okay, so essentially there's going to be 2 parts to your problem. And there's 2 different types of compound inequalities. Okay, one of them is called an intersection. We determine that that is the type of problem because there's a key word and written in your problem. Okay, and when you have an intersection and you graph, you're looking for the overlap of your 2 answers. Okay, so these are just your keywords. I'm going to show you how this all works. So an intersection is an and problem, and it takes the overlap. The other type is a union. Okay, and a union takes the keyword of or, and you're going to shade everything that you graph. And again, I'm going to show you how to do all of this. Okay, these are just your definitions. So I have here, these are 2 problems. X is greater than 7 and x is less than or equal to 13. So this is a compound inequality because there's 2 parts. Okay, this is also an intersection problem because there's a key word of and. Okay, so we said the intersection, we're looking for the overlap. So we're going to graph both of these problems on the number line together. And you want to make sure that you put them in numerical order. So 7 goes here and 13 goes over here. 7 would have an open circle and 13 would be closed. Okay, so greater than 7 goes to the right, and less than 13 goes to the left. Okay, now this is not our final answer. All I've simply done is use arrows to indicate my two answers, but I have to shade. I have to determine where the shading is, because the shading is the final answer here. So for an intersection, you want to take and shade where your two arrows overlap. So where does this problem happen to overlap? My two arrows overlap right here in the middle. So that is where I'm going to shade. Okay. The answer to an intersection problem can be written in this sandwich type inequality where we use both numbers with one variable. Okay, so since the variable, we don't need it to repeat since it's the same one. Okay, so 7 is less than x is less than or equal to 13. Okay, so see how we read our number line in numerical order, and that's the order that we use for our answer here. So the 7 is on the left and the 13 is on the right. Okay, so that's how we graph an intersection. Let's see how we graph a union. So again, here are two problems. Okay, and there's a keyword of or, so that's how I know that it's a union. Okay, so I'm going to put these on my number line in numerical order. Okay, use my appropriate circles. So less than -5 is going to go to the left, and greater than 6 goes to the right. Okay, so a union, we shade everything we graphed. So what did I graph? I graphed the arrows. So we're going to shade anywhere that you have an arrow. So there's one over here, and there's one over here. Okay, so both pieces of that shading is my final answer. Okay, there's not a fancy way of writing the answer to a union. We have to just use the word or. Okay, we can't put them together in a sandwich because you see we have two pieces of shading. They're not sandwiched together like the last example. Okay, so this was just how to do the shading. Let's look at actually solving some of these problems. Okay, so now even though it says the word or, okay, we must solve both problems. The or does not mean that it is a choice. The or is simply telling you this is a union. That's the key word. So we're going to solve each of these separately. Okay, so there is the first answer. And here's my second answer. Okay, so x is less than or equal to 1, or x is greater than or equal to 4. You want to make sure that you include the key word when you write your answer. Okay, and now we're going to graph. So I'm going to put each of my answers on the number line. Use the appropriate circles. Okay, and I'm going to put arrows down before I shade. Okay, so less than 1 goes to the left, greater than 4 goes to the right. And now a union, we have to think, well, what does a union take in the shading? A union takes everything that you graphed. So I graphed over here, and I graphed on the right. Okay, so that is my final answer. X is less than or equal to 1, or x is greater than or equal to 4, and the accompanying graph that shows that. Okay, hopefully you didn't find that to be too difficult. So let's try another one. Okay, I now see this says and. That's the other type of problem. And is an intersection. Okay, so solve both of these problems. Okay, in compound inequalities, we always solve both equations. Okay, and multiplying or dividing by a negative is still the rule in compound. Okay, so I have my two answers, and I'm going to put them on a number line. Okay, always make sure that your numbers are in the appropriate order on the number line. Okay, and I have my open and closed circle. All right, so 4 is going to go to the right, and 10 is going to go to the left. So now I have to think, what kind of shading do I use for an intersection? An intersection, you shade where the arrows overlap. So where does this problem overlap? Here in the middle. Okay, when your shading overlaps in the middle, you want to write your final answer like that sandwich inequality. So we start from the left, okay, and we use the 4. It's always going to be less than or less than equal to. Just look at your circle. So this is just a less than. Your variable gets sandwiched in the middle. Okay, it's another less than, but we refer to our circle to tell me that it's an equal to. And then we put our second number on the right. Okay, so this sandwich implies that there's an end keyword. Okay, you see the word end in sandwich? Okay, so when I look at the answer in this bubble here, I know that it is an intersection problem because it's written as a sandwich. Okay, you could write your answer like this. Okay, it's not wrong. Okay, but the preferred method is that sandwich. All right, let's keep going. Okay, so now this doesn't have a word in it. I have not seen a problem written this way. Okay, I don't have a key word, but I see that it's written as a sandwich. And if I go back for a second, look how I wrote my final answer here. I wrote this as a sandwich. So I'm wondering if that means that this is an and problem, because this is a sandwich. Okay, and it is. This is an intersection problem. Okay, it's just written in a different way. So in order to solve this, we have to split it up. Okay, see how there's two inequalities? So we're going to share what is in the middle. So x minus 4, okay, and we're going to split it up. So we're going to take everything from the middle over to the inequality symbol. So my first one is negative 5 is less than x minus 4. And, okay, now we're going to take everything in the middle again and go to the other inequality symbol. X minus 4 is less than 2. Okay, so the x minus 4 is going to show up in both problems. Okay, but it's important that we split this up to solve, so it's going to make it much easier for us. Okay, and now look, I have my variable on the right side. We know that we like to have it finish on the left. So I'm going to switch sides, and I'm going to make sure that my symbol is still pointing in the correct direction when I rewrite. Okay, and now I solve my second one. Okay, and I have my two answers that I'm going to put on my number line. Okay, so I'm going to use -1 with an open circle and 6 with an open circle. So -1 is going to go to the right and 6 will go to the left. So where do I shade an intersection? I shade where the arrows overlap. Okay, so this one is overlapping in the middle. Okay, and remember, you can write your final answer as a sandwich. -1 is less than x is less than 6. Okay, when your shading is in the middle like that. Okay, so remember, when the problem does not look like it has a key word, it's probably an and you're going to split it up into two equations and make sure that the middle portion is repeated in each equation. So in this case, x minus 4, you see that it shows up on both of my equations. Okay, of course you didn't think we were going to get out of this without some special cases. Okay, so I have an and means intersection. Okay, so let's go ahead and solve these to see, well, what is so special? Okay, so far nothing special about my solving or my answer. That seems pretty normal. Okay, still normal. I have two answers. So it must have something to do with the graph. Okay, so putting these on a number line, open and closed circle. All right, greater than 3 goes to the right. Greater than or equal to 7 goes to the right. Okay, so I have to think to myself, what do I shade in an intersection? An intersection, I shade the overlap. So where are these two arrows overlapping? It's not the middle anymore. They're overlapping over here. So now when I write my final answer, I kind of have to read the graph here and make sure that both of the statements that I solved with are even part of my final answer anymore. And they're not, because the 3 is not included in any of the shading. Only greater than the 7. So my final answer here, okay, is really x is greater than or equal to 7. Okay, and that's the whole inequality portion. Okay, because you're only shading where they overlap, and they happen to overlap there at x is greater than or equal to 7. Okay, so the 3 does not affect your final answer. Okay, let's see if we have more special cases here. All right, let's see what this one has in store. So here I see I have and. Okay, so again, I'm looking at an intersection. So let's solve these. Okay, so it doesn't seem to have anything to do with the answer. It seems to be in the graph. going to combine like terms. And move my smaller variable. Okay. All right, so I have my two answers. I'm going to put them on a number line. Okay, so it's an intersection. So I would want to shade the overlap. Okay, where are these two arrows overlapping? There is none here. Okay, because there is no overlap, you cannot shade. The only place that you're allowed to shade in an intersection is where your arrows overlap. And if that does not occur, then there's no shading. And no shading means no solution. Okay, if you cannot shade, there is no answer that can satisfy both of those equations that you got. X cannot be less than or equal to 3 and be greater than or equal to 9. Okay, so my final answer for this problem is no solution. Okay, and it's no solution because of the graph, because there is no overlap, and this is an intersection problem. Okay, one last problem. All right, this is an OR. So now this is a union. Okay, when I solve this one, oh, my rule has emerged here. I've divided by a negative, so I need to flip my sign. Okay, so I get x is less than 3. Okay, and then okay. All right, so put those on a number line. Closed circle and an open circle. Make sure they're in the correct order. All right, so less than 3 goes to the left and less than negative 14. All right, so what do we shade in a union? A union shades everything that was graphed. Okay, so anywhere that I have an arrow on the number line, there should be shading below it. Okay, so I have arrow over here, keeps going, keeps going, keeps going. Okay, even though there's a double arrow, that doesn't change anything if there's at least one that you shade for a union. Okay, so now we need to read our number line to determine, well, what is our final answer really here? Okay, because my shading, situation ended up being a little weird. This is a special case after all. So since my shading goes right through the negative 14, I don't really have to worry about stating that in my final answer, because the shading going through it implies that x is going to be less than or equal to negative 14. So the only thing I need for my answer is x is less than 3. Okay, since the shading goes right through this other number, I don't need two statements as part of my final answer. Okay, so the really important thing about compound inequalities is that you remember what each one takes. So an intersection takes the overlap, and a union takes everything that was graphed. If you remember those two principles, you will be fine when you create your table of values. Okay, so this is the end of your notes for 4.1 and 4.2. Please make sure you have all of these examples down. Each one is very important, okay, and include any questions that you may have. All right, thank you guys so much for watching, and I will see you in